Okay, let's talk about an awesome way to evaluate functions. Now, hopefully, you're pretty familiar with the concept of functions and evaluating functions. You should be if you're at the, let's say, the pre-algebra level or beyond, certainly like the Algebra 1 level first year algebra course. But let's just talk about what it means to evaluate a function, just in case you forgot. So here is an example of a function. So a function is basically just a rule in algebra, and we can describe it here as this particular function, f of x, that's the name of the function, is equal to 4x cubed minus 2x squared plus x plus 5. Now, if I want to evaluate a function, in this case, let's suppose I wanted to evaluate this function for 2, what I want to do is find f of 2. And all I'm going to do is replace this x with a 2. You can see there's a 2 here where this x spot would be. So all these x's right here, I would replace with a 2, and then I would do all the number crunching and get my final answers. That's what it means to evaluate a function. And probably most of you out there are familiar with this concept or this skill. So if you can evaluate this function just basically the way I described it, go ahead and put your final answer into the comment section. I'm going to show you the correct result here in just a moment. But after we look at the answer, I'm going to talk about another technique, an awesome way that is completely different than the way I just described to evaluate functions. And this is going to be kind of an introduction to something that's going to be taught at a little bit more advanced mathematics. So if you're in first year algebra, you may not have seen this yet, but certainly if you're in like Algebra 2, pre-calculus, college algebra, those type of courses, this is something that you definitely are going to need to know. But I'm just going to quickly kind of introduce this concept for not only those students that are in this at that level of mathematics, but for those of you that are not at that level, that you just want to see this new, different way. Believe me, if you just stick with me for a couple minutes, you'll understand this concept that you'll be learning a lot more about later. But anyways, before we get going, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades. I absolutely love helping people learn mathematics. And I'm going to tell you right now, all of you can be successful in math. And I'm especially speaking to those of you that are having a tough time in math. As long as you have the desire to learn math and you have some encouragement, right, some sort of coach, and hopefully you have a great math teacher. But the most important thing you need to learn math is great math instruction. Like math instruction you actually understand, clear, understandable, and comprehensive. So if you need help in your current math course or maybe some sort of special test you're getting ready for, something like the SAT, ACT, GED, GRE, GMAT, maybe the ASVAB or teacher certification exam, or if you're homeschooling mathematics, check out my math help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span these categories and much, much more. I'm also going to leave links to my math notes in the description as well because so many students take inadequate notes. I was that way back in the good old days. I thought I was taking great math notes because I had my paper there and I would just write stuff down when the teacher was talking. And then I would look at my notes and I had no idea what I wrote down. And a lot of it had nothing to do with math because I was probably talking to my best friend, sharing notes. You get the idea. Listen, math is a game of focus and note taking is a skill. The better you get at note taking, the better you're going to be at math. But in the meantime, you can use my notes if you like. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and evaluate this particular function for f of 2. What is going to be the answer when we do that? Well, this function evaluated for 2, or f of 2 of this function, is 31. Okay, so I kind of told you how to do this work, right? I would plug in a 2 here, a 2 here, and a 2 here. So it'd be 4 parentheses 2 cubed minus 2, then parentheses 2 squared plus a 2 for this x right there, plus 5. So what we need to do is follow the order of operations. And when you do all of this lovely math work, you should have gotten a 31. All right, so hopefully you were able to do this correct. If you weren't quite sure what to do, you can kind of double check yourself or try this again. But for those of you who got this right the first time, Very impressive. Definitely, you've earned a nice little happy face, an A plus, a 100%, and a few stars in your ability to evaluate a function. Nice job. Okay, so here's the deal. This type of problem, what I just described to you right here, evaluating a function, this is a very typical, let's say, Algebra 1 type of problem, and even like a pre-algebra problem as well. Now, when you start getting into a little bit more advanced math courses like Algebra 2, which comes after Algebra 1, second year algebra, college algebra is kind of another term for it. Now, after you take those courses, you'll get into, if you want to continue to learn mathematics, you'll get into things like pre-calculus. So you start learning more advanced stuff about this topic right here. Okay, we're talking about functions, but really what we're talking about is something called polynomials. I'm sure all of you have heard that name, but we're talking about polynomials, advanced theories and concepts about polynomials. Polynomials are a huge topic in mathematics, and one of the things that we do with polynomials, all right, you could certainly multiply polynomials, add them, subtract them, and divide polynomials. We're really talking about polynomial division. So some of you might be saying, okay, Mr. YouTube Math Man, you're giving me a lot of theoretical concepts here. You're talking about polynomial division. I thought you were going to teach me another, like an awesome way to evaluate functions. Well, I am going to teach you that, but I want to kind of set this up that this is a big topic, kind of full of a lot of advanced concepts, nothing that you can't learn, okay? But just so you know, if you're interested in learning more about this, what you would want to look into is theories of polynomials, polynomial divisions, etc. And you're going to find that again in these levels of math courses like Algebra 2, etc. Okay, so let's go ahead and get into this. And I'm only going to briefly highlight this because I don't want to turn this into a formal instruction. It would take a lot of time to do this. By the way, if you're at this level of math and you need help with this, or if you're interested in learning this, well, check out like my Algebra 2 course, pre-calculus course, college algebra course, whatever level you might want. I teach all of this theory of polynomials in there. But what we're going to be talking about is something called the remainder theorem. Remainder, wow, what is that? It sounds kind of like what we do in division, right? If I go 7 divided by 3, yeah, actually, let me do this right here, right? So if I say, all right, 7 divided by 3, that's 2, right? 2 times 3 is 6. And what do I have? I have 1 left over. I have a remainder of 1. Are we talking about that kind of remainder? Yes, we are, okay? So we're talking about division. And when you divide, you can have a remainder. But here's the deal. We're not dividing numbers. We're dividing polynomials. So again, big topic, but I'm only going to teach you this one little kind of portion of, polynomial division, and it's called the remainder theorem. And it's going to use this little shortcut technique called synthetic division. So I know a lot of you are like, I don't understand what you're talking about. Well, listen, you'll see the kind of setup here in a second. But anyways, I think that it's, it's not beyond your ability to understand what's going on. All right, but let's just take a look at this remainder theorem. It says the remainder of a polynomial divided by x minus k is equal to f of k. All right, so this is what's going to allow us to evaluate this function in another way. This right here may not make any sense to you, but when you see it in action, I think it will make perfect sense to you. So let's go ahead and take a look at what's going on here. All right, so here is our problem. So here is our function, and we are evaluating this function for 2. We're finding f of 2. We do all this number crunching, and you get 31. So you can see the work here just in case you had problems with that initial setup that I described earlier in the video. But f of 2 of this particular function is equal to 31. And this is going to be, right, the answer to evaluate this function for 2 is, again, 31, and it's going to be the same as doing this, all right? So what are we looking at right here? Well, this is basically what we call synthetic division, okay? It is a shortcut to polynomial division. So let me just back up here before I go into this. If I have this polynomial, this function right here, let me erase this because we have a nice polynomial. And let's say I want to divide this polynomial, okay, this polynomial by this polynomial, right? This is a polynomial and this is a polynomial. So here is a division problem. This divided by this. This is what we're talking about. This is polynomial division. This is a big topic, again, at more advanced levels of mathematics. But a shortcut that we can use when we have polynomial division problems where we're dividing one polynomial by a polynomial, what we call a linear factor, something with just an x, not an x squared. So a nice little lovely little polynomial like this, we can use this other thing called synthetic division. All right, so I'm just going to show you the step here because I don't want to get too technical where some of you get totally lost in this video, but let's just take a look at the procedure here. So you see these numbers 4, -2, 1, 5. Just focus in on these numbers here 4, -2, 1, 5. And I'm going to start simplifying these concepts right now. So don't run away. Don't leave the video. Be like, okay, I'm totally lost, totally confused here, Mr. YouTube Math Man. You see these numbers right here 4, -2. Now, what's in front of this x? There's really a 1 there, okay? We're looking at the coefficients. So this polynomial is written in standard form, okay, highest to lowest power. So we have x cubed, x squared, x, and then 5. Now, if we didn't have all the powers represented, we could just throw in a 0. So what we're going to be doing is using the coefficients, all right, of these terms of this polynomial when it's written in standard form. So we have a 4, a -2, a 1, and a 5. All right, so this is just going to be a simple illustration of this little technique. So here we have 4, -2, 1, 5. So these are the coefficients of our function. Now, look here, I have a 2. I'm going to be dividing that polynomial by this 2 using this thing called synthetic division. Now, this 2 is representing this 2 here in this function, f of 2. I'm putting a 2 right here. So here is a setup. So, or here is the setup to do this problem. So what you do is kind of draw this long L thing like so. And now I'm going to go ahead and explain how we get the answer. So here is how you do synthetic division. All right, so you see this number right here, 4. You're going to drop it down. You're going to put it right here, okay? All right, so hopefully you understand what's going on. So now what we're going to do is this. 2 times 4 is what? That's 8. So you put the answer to that multiplication. 2 times 4 is 8. You put it right here. Okay, 2 times 4 is 8. You put it right there. Now you're going to add down this column. -2 plus 8 is what? It is 6, okay? So we're going to do this again. So 2 times 6 is what? It's 12. We'll put the answer right there. Then we're going to add down. 1 plus 12 is what? 13. We're going to do this again. 2 times 13 is what? The answer is 26. And then we're going to add down. 5 plus 26 is 31. And now we basically run out of numbers to work with. Okay, we're at the, once we finish, we are done. So notice this last number here, you're going to put a little line. This is the remainder. Okay, this is the remainder of doing this problem. But let's look at this number, 31. Doesn't that look pretty familiar to you? Doesn't that look like this f of 2 when we evaluated this function, we got the answer of 31? Well, this is 31 as well. Well, does it mean that is it representing the same thing as evaluating this function for 2? It does, okay? This is the remainder theorem. Basically, it says the remainder, effectively, and I'm kind of paraphrasing this, when we do this synthetic division, the remainder is going to be the same as taking this number and evaluating that function by that number, okay? The answer will be the remainder. All right, so let's go ahead and just practice this again. All right, just to make this extra clear, though, I wrote this down. The remainder theorem allows for another cool, awesome way to evaluate functions for values. So let's take a look at another example of this, though. So just to practice this setup, let's suppose I wanted to take this polynomial and divide it by another polynomial like this. So this is 2x squared minus 3x plus 1, and we're gonna divide it by x minus 5. So when you have what we call linear factors, nothing like x squared or x cubed, when it's just a power of x and a number like this is what we call a linear factor. And I'm kind of, paraphrase or just using loose language here so those you can understand. This is when we can use this particular little shortcut. All right, if I had an x squared or something like or larger polynomial, I could not use this cool little shortcut called synthetic division. All right, so let's go ahead and divide this polynomial by this polynomial. And if you recall, let me go back up here, and maybe now we can understand this remainder theorem a little bit better. It said the remainder of a polynomial divided by x minus k. So in this case, it was this problem that the second example I'm doing, it's x minus 5. All right, that's what I'm dividing to. It's equal to f of k. So it's equal to f of, remember, it's minus k. So this is 5, right? That's x minus 5. That's the k. So this is going to be equal to f of 5. All right, if you're a little bit confused on this, just stick with me. I think through the second example, you'll get a better sense of this. But again, what we're doing is we're looking at another way to evaluate a function. Okay, so here is how we can use synthetic division. So when you have x minus a number, you're going to put that number right there. So x minus, it's not x plus. If I had x plus 5, I would have to think of this factor as x minus a minus 5. Okay, so I would be using a negative 5 right here. So it's always x minus something. All right, so let's go ahead and look at this now. X minus 5, so I'm going to use the 5. Okay, this is already set up for me right here. And now I'm going to use the coefficients again. This is written in highest to lowest power, x squared, x, and a number. So here's 2, negative 3, and 1. And I got my nice little L here. So let's go ahead and practice this procedure again. All right. So what's the first thing I'm going to do? The first thing is I'm going to drop that 2 down. So 2 goes right here. Okay. Now, if you want to go ahead and practice the rest of this, you're like, okay, you kind of remember what to do. What's the next step? Well, after you drop this 2 down, it's going to be 5 times 2 is what? Well, the answer is 10. You're going to put that right there. Okay. So we're doing synthetic division. All right. So let's just kind of look at this right here. I kind of pre-wrote this. So 5 times 2 is 10. You put the answer in the next column. Now you're going to add down. Negative 3 plus 10 is what? Positive 7. So now you're just going to go ahead and repeat. Okay, so here it is. We're going to have 5 times 7 is what? 35. So we're going to add down. 1 plus 5 is 36. Okay, so what does that mean? Okay, well, there's our remainder. It's 36. So it means that if we evaluate this function right here, okay, let's kind of erase this. Well, we'll just leave this in. If we take 2x squared minus 3x plus 1, and let's call this the function f of x is equal to 2x squared minus 3x plus 1. And I said, hey, find f of 5. Okay, or evaluate this function for 5. Find f of 5 of this particular function. It's the same thing as synthetically dividing by this number. Okay, so the answer is going to be right here. It's going to be 36. All right, so let's go ahead and just check this to make sure this works out. All right, so again, we have a polynomial division set up here. Let's go ahead and just express this as a function. F of x is equal to 2x squared minus 3x plus 1. And let's go ahead and evaluate this function for 5. It should be the same thing as synthetically dividing, but let's just go ahead and do it the most direct path. So we'll plug in 5 everywhere there is an x. So what are we going to get here? So we're going to get 5 squared. 5 squared is what? 25 times 2, that's 50. And then this would be 3 times 5, which of course is 15. Plus that 1, 50 minus 15 plus 1 is 36. F of 5 is equal to 36, and I'm pretty sure that's the same thing we got over here with our remainder. Okay, all right, so hopefully those of you out there are new to this, hopefully this wasn't too confusing. I know it's probably a bit confusing because I'm just kind of attempting to introduce you to some cool techniques that you're going to be learning when you get into a little bit more advanced mathematics like Algebra 2. So I guess this video is kind of directed at those of you that are just learning Algebra 1. But again, this right here, if you just read it by itself, could be, it won't make much sense if you don't actually see problems and examples, etc. But this is really, I guess the bigger point here is in when you're learning more advanced math or any math, math builds upon itself, right? That's why you have to take notes. How can you possibly remember all this stuff without taking great math notes or just working on learning things one skill at a time? And what ends up happening for a lot of students, they find themselves at the Algebra 2 level, college algebra level, pre-calculus, and they don't remember how to do all these kind of prerequisite skills. They're like, oh my goodness, I don't know how to do this, but I have to pass my test on this. Listen, you can't force yourself to learn something that you forgot how to do or you never learned it in the first place. So if you want to be successful in math, especially at this level of math, what you have to do is keep up and you'll pay the price. Like, hey, if you struggle with math for a long time, for whatever reason, pay the price by taking the time to do that additional work to review and relearn things, right? It's going to pay off in the long run. I try to bring a message of hope, to those of you out there that are learning mathematics or are struggling with math, but I'm also very realistic and honest. Okay, I'm not going to tell you that, oh, you can just learn this stuff 1 2 3. No, it takes work, right? You have to be committed, you have to stay focused, but the most important thing, again, is having great math instruction, all right? Not, being taught this stuff in such a technical way where you're not understanding what's going on, even if you're trying to work hard to learn this. And that's where I tried to help those of you on YouTube or those of you that will be members of my Math Help program. Okay, so if you want to learn more about this stuff, again, the courses to check out would be Algebra 2, College Algebra, Pre-Calculus if you're at those respective levels. But again, if you're at that more basic Algebra 1 level, don't panic too much if you don't completely understand this. You'll get this stuff in a year or two. All right, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.